Ochem University. I'm Eric, I'm your host, and I'm going to be going through all kinds of reaction problems with you today. First, we're going to do some alkene reactions. Now, before we do that, I want you to know, check out OchemUniversity.com. I have plenty of practice problems already created, worksheets, practice quizzes, practice exams, even practice videos with tutor sessions. I have over 100 videos and an online Q bank. Plenty of resources for you to practice. Now, we're going to be doing a session here. I'm going to be going through it a little bit more slow, but that's because I want you to get this reaction and understand it very well. Again, if you want more resources, plenty of practice problems and all kinds of worksheets, definitely head over to OchemUniversity.com. You can also check out OchemTutor.org or OrganicChemistryTutor.org. Plenty of resources, okay? Reach out to me if you have any questions. So let's go ahead and get started. Okay, so our first problem here is actually trying to elucidate the formation of a secondary alcohol. Let me go ahead and draw that though, since it's a little bit blocked off here. So, if we zoom in, we can actually see our problem over here now. So we have this alkene on the left, and what we're trying to make is a alcohol functional group on the right. What are some ways that we might be able to do that? Well, first I'm thinking we can do hydration. We can do H plus H2O or H2SO4 and water. That might get us the right answer that we want, but do you see any kind of limitation that might be preventing us from doing that? Well, I see that next door there is a more substituted carbon group here. And if that's the case, when we put our carbocation located on this carbon, then we're going to get a rearrangement. So we're going to have to think a little bit differently in order to get this secondary alcohol that we want. It's a substituted secondary alcohol, and it's not a primary. So I'm thinking we do something like oxymercuration-demercuration. We can directly place that OH group on the secondary, versus if we were to do hydroboration, then that's going to be more of a anti-Markovnikov, right? But we're looking for more of a Markovnikov type of reaction problem here. So what I'm going to do, I'm going to react this with HgOAc subscript 2 plus water, and that's going to be my first step. And then my second step is going to be NaBH4. Now, if you want the full mechanism, I definitely recommend checking out my website. I go through the whole mechanism, so you should watch that video if you're interested. So remember, this is going to do a Markovnikov addition of H2O. If you want to do a anti-Markovnikov addition and maybe put that answer in the less substituted or in the primary spot, then you would have to do something called hydroboration, oxidation. So that's going to be a different video. We can do that in the future. Today's video is just focused on the oxymercuration-demercuration and placing that OH group on the secondary. Again, remember, limitation, if I reacted this with H plus and H2O, we're actually not going to get that OH functional group on the secondary carbon. It's going to go on to this tertiary carbon instead. So here's tertiary, here's secondary, and there's primary. And so when the alkene group reaches out and grabs the proton, it's going to leave behind a proton. It's going to leave behind a carbocation at the secondary spot, and then there's going to be a hydride shift pushing that positive sign over to the tertiary. And so because of that, then you're not going to get the location of the OH in the right spot. It's going to go to the tertiary spot. So we'll do more practice videos like this. I just wanted to put this one out here. If you need the full mechanism, again, check out my website. I walk through the whole mechanism. We can do that together. If you're interested in anything particular, I cover the entire organic chemistry series. If you want more resonance or bond line structures, leave a comment. If you're looking more for advanced reactions like benzenes or phenols or maybe reactions of amines or carboxylic acids, definitely leave a comment. So let me know what you're interested in, and I'm excited to help you on this journey together. All right. Again, make sure you check out organicchemistrytutor.org or ochemtutor.org. Lastly, you can check out Ochem University.com. Okay. All right. Thanks for tuning in, and we'll see you next time.